Section 4.2 is on the standard form of a quadratic function. The standard form of a quadratic function is f of x equals ax squared plus bx plus c, where a is not equal to 0. Here are some of its properties, and some of this should look familiar from Algebra 1. So the graph of f of x equals ax squared plus bx plus c is a parabola. If a is positive, the parabola opens upward. If a is negative, the parabola opens downward. The axis of symmetry is the line x equals negative b over 2a. That is also the x-coordinate of the vertex, and the y-coordinate of the vertex is the y value that you get when you plug that number in for x. The y-intercept is the point 0c, so whatever number out here doesn't have an x, that's going to be your y-intercept. And here are a couple basic graphs of what it might look like. So let's try an example. So for the function y equals negative x squared plus 6x plus 3, what are the vertex, the axis of symmetry, the maximum or minimum value, and the domain and range? So looking at this, a is equal to negative 1, so that means that my parabola is going to open downward. Okay, b is equal to 6, and c is equal to 3. So I need to find my vertex, so my vertex is going to be x equals negative b over 2a, or negative 6 over negative 2, or the x of my vertex is 3. Now to get my y value, I'm going to plug 3 into that equation for x. So negative 3 squared plus 6 times 3 plus 3. And remember PEMDAS, I'm going to square first and then multiply by a negative 1. So that's going to be equal to 9 times negative 1, which is a negative 9, plus 18 plus 3, or y is equal to 12. So my vertex is the point 3, 12. My axis of symmetry is the line x equals 3. Remember, don't just write 3. It is the equation of a vertical line, x equals 3. Because my parabola is opening downwards, it's going to have a maximum value. And my maximum value is going to be y equals 12, because that is the y-coordinate of the vertex. My domain is going to be all real numbers. And my range is going to be y is less than or equal to 12, because 12 is my maximum y value and all of the other values are less than that. It's going to be a less than or equal to. Okay, here's our next example. We need to graph the function y equals 4x squared minus 16x plus 10. So the first thing I'd like to do is find my vertex. So I'm going to do x equals negative b over 2 times a, and that's going to give me 16 over 8, or 2. To find my y, I'll plug that in. 4 times 2 squared minus 16 times 2 plus 10. 2 squared is 4, so that's going to give times 4 gives me 16, minus 32 plus 10, which gives me a y value of negative 6. So my vertex is the point 2, negative 6. I'll go ahead and graph that. 2, 4, 6, 2, negative 6. My y-intercept, because c is equal to 10, that means my y-intercept is going to be the point 0, 10, which is up here. And just looking at that, that tells me I'm going to have a very skinny, a very narrow parabola, which makes sense because my a, my coefficient of x squared, is a whole number greater than 1, or a number greater than 1. So I think I'm just going to make a little table of values here just to get a few other points. So I know that 0, 10 is 1 point. I know that 2, negative 6 is another point. What do I get if I plug in 1? So plugging 1 into this function is going to give me negative 2. So 1, negative 2 is another point. Now my axis of symmetry is this line right here, x equals 2, so I can just translate these points across that to get a couple other points. And there is my quadratic function y equals 4x squared minus 16x plus 10. Next example, what is the vertex form of the function y equals 2x squared minus 3x plus 2? So remember, vertex form is y equals a times the quantity x minus h squared plus k. So I need to figure out what are what are h, k, and a. So let's start with, so my h is going to be the x of the vertex. So I'm going to do negative b over 2a. So negative 3 over 2 times 2 is going to give me 3/4. To find my k, that's the y of the vertex, so let's plug 3/4 into there. So 2 times 3/4 squared minus 3 times 3/4 plus 2 gives me 2 times 9 over 16, which is the same as 9/8 minus 9/4 plus 2. Using my calculator and then putting it back into decimal form, into fraction form, gives me 7/8. So my vertex is the point 3/4, comma 7/8. So this is my h, this is my k, and looking at my original problem here, I know that a is equal to 2. So my final answer is going to be, because the a is the same, the a of ax squared is the same as the a in front here. So vertex form is going to be 2 times the quantity x minus 3/4 squared plus 7/8. And it's a good thing we don't have to graph that, because I don't like graphing fractions. Okay, and our last problem here is a word problem. So the model for the performance of a stock is P equals negative 3d squared plus 50d, where d represents the number of days of trading and P is the price per share. So in other words, the price per share is dependent on the number of days of trading. So basically an ordered pair would look like d comma p. D is our independent variable, P is our dependent variable. What is the maximum price per share of stock? So basically, and I know because it starts with a negative, I know my graph is going to look something like this. It's going to be an upside down, a parabola opening downwards. My vertex here is going to be the point D comma P, and I want to know what is the maximum price per share of stock. So I need to know what is P right there. So that's the vertex of this parabola. So let's do negative b over 2 times a. That's going to give me negative 50 over negative 6, or 25/3. So that's really the x-coordinate of this vertex here. Plugging that into the function, so let's find p of 25 over 3. Plug that in. So negative 3 times 25 over 3 squared plus 50 times 25 over 3 gives me some kind of funky fractions here. So 25 over 3 squared and then multiplying that by negative 3 gives me a negative 265 over 3 plus 1250 over 3, or positive 625 over 3, which is approximately equal to, because we're looking for price per share, we're looking for money. This is actually 208.3 repeating, but since we're looking for money, it's going to be $208.3 repeating would round to 33 cents. So in this section, we took a look at standard form of a quadratic function, which you may remember from Algebra 1, being f of x equals ax squared plus bx plus c. We looked at how to find the vertex, the axis of symmetry, the maximum and minimum value, and then how to turn something from standard form into vertex form.